Okay, let's go over the Unit 3, or Part 3 test for Unit 3. You know what I'm saying. Alright, so list the characteristics of the function. Click my mice here, say check. Nope, that's not right. I want it to be blue. Wonderful. Alright, so number one, domain, as y'all were telling me in class, look left to right. It's going to be negative infinity to infinity, or all real numbers. Range, look at the asymptote. That's going to be at the 3. So range is going to be 3 to infinity. And again, we just talked about the asymptote being 3, so y equals 3. X-intercept, there is none because it doesn't even touch the x-axis. Y-intercept is going to be 0. And, we can't say it's going to be 3. I think in class we said it's 3. But remember, if we plug in 0 for x and then find y, we'll get 3.008. Really close, but not quite 3, okay? Because if it was 3, then that means it touched the asymptote, which is not supposed to happen. Remember, plug in 0 for x and then solve for y, okay? So, zeros, none, because it doesn't touch the x-axis. In behaviors, we talked about it, as x approaches negative infinity, y approaches infinity, and as x approaches infinity, the y approaches 3. Intervals of increase, this is a decay graph, so there's none here. So since we're talking about decay, then this is negative infinity to infinity. Okay, so finding the rate of change, if you plug in negative 4, we'll get an 8 back, and if you plug in negative 3, we'll get a 4 back. Plug these values in, you get 4 minus 8, all over negative 3 minus 4. You get negative 4 on top. Negative 3, this turns into a positive 4. So 2 negatives make a positive. So that's 1. My answer is negative 4. Now it says using the function above, write a sentence describing transformation of the base function. Remember to name the function linear, nonlinear, or exponential in your sentence. So, I'll go ahead and write all this out. We're going to say the exponential function. You know what? I'm going to type it out. Yeah, let's type it out. Let's see, we need to change the font, make the font a little smaller. Maybe 24. So this exponential function p has a decay rate of 0.2, has a vertical stretch of 5, a horizontal shift left 4 units, and a vertical shift up 3 units. There we go. Now, granted, I'll understand if you're talking about decay rate. I'll understand the vertical stretch 5. I know we talked about arguing the 0.2 and 5, etc. I'll understand the horizontal shift left 4 units because of the positive 4, and a vertical shift up 3 because it's a constant 3. Okay? So like I said, I'll be lenient on this decay and the vertical stretch of 5, okay? I'll be lenient there, but the shifting, no, y'all got to get that, okay? So the next one, again, in class, we said the domain is going to be all real numbers. Oh, I hit my marker. All real numbers again, range, all real numbers, asymptote none, x-intercept to 0, y-intercept 0, 6, 0 is going to be x equals 2. Remember, we got that from the x-intercept. In behaviors, as x approaches negative infinity, y approaches infinity, and I was about to say Anthony, that'd be weird. X approaches infinity, and y approaches negative infinity. Intervals of increase, we're going to say none. And intervals of decrease, negative infinity to infinity, because this has a negative slope. Okay? Let's see, scroll down. So the rock is between negative 2 and 2. So remember in class we said negative 2 was 12 and 2 is 0. Plug that into the formula, we get 0 minus 12 over 2 minus 2. Get negative 12. Two negatives make a positive. So 2 plus 2 is 4, and we get negative tree. Alright, and again, writing a sentence. So I'm going to get my keyboard back in front of me. So again, this is really big font. This linear function d has been reflected over the x-axis. Reflected, there we go, x-axis. Vertically stretched by 3 and has a vertical shift up 6 units. Again, I'm just being completely detailed here, but I'll understand and say vertical shift, vertical stretch, all that, and the reflective part, okay? Number 3. Again, all real numbers, range, we have that asymptote down here. So that's going to be negative 10 to infinity. Asymptote, we just talked about it, y equals negative 10. X-intercept, 1, 0. Y-intercept, 0, 10. Zeros, x equals 1. Remember, we got that from the x-intercept. In behaviors, as x approaches negative infinity, the y approaches infinity, and as x approaches infinite, oh my good grannies, as x approaches infinity, there we go, y is approaching negative 10, the asymptote. Intervals of increase, again none, this is a decay, so negative infinity to infinity. Alright, finding the rock. Again, I'm using points, so 0, 10 would be the first. Okay, remember, x is 0, go to the 0, it's 10. We talked about this in class. And then 2 would be negative 5. So plug it in, we get negative 5 minus 10, all over 2 minus 0, equals negative 15 over 2. And I think we called that negative 7.5. Alright, let's see y'all. Oh, next part's the sentence, so I'm going to scroll down, click, scale this down a little bit, 24. So again, a nice sentence would be, this exponential function f has a decay rate of 0.5, has a vertical stretch of 20, and a vertical shift down 10 units. And that would be a complete sentence. Okay. Moving on. Number 4. I think I don't know, did we get halfway with this one? Maybe so. So again, domain is going to be all real numbers. Range, we have another asymptote right here. That's going to be -2, so negative infinity to -2. Remember, we're going bottom to the top. Asymptote, y equals -2. We talked about that. X-intercept, none. Doesn't touch the x-axis. That was weird. We'll put that x there. Y-intercept will be 0, -12. Excuse me. There's no x-intercept, so we have no zeros. As x is approaching negative infinity, y approaches -2, and as x approaches infinity, then y approaches negative infinity. That's supposed to be an arrow. Swoosh. All right, intervals of increase, again, none. Decrease, negative infinity to infinity. Rock, if you plug in -1, we'll get -7 back, or you can search it right here. -1 down to 7. And 0, -12, and we already have that because that is the y-intercept. Again, plug all these values in, we get -12 minus -7 all over 0 minus -1. All these two double negatives turn into positives. So -12 plus 7 is going to be a -5. Two negatives from that one turn into a positive, so 0 positive 1, or excuse me, 0 plus 1 is 1. So this is going to be -5. Again, if we wanted a nice pretty sentence to go with this, we're going to say, change the font because it's really too big. Alright, we're going to say the exponential function h has a growth rate of 2, but has been reflected over the x-axis. Oh, lost my spot. Has a vertical stretch by 10 and vertically shifted down, down 2 units. Now I know it's weird to say growth for this one, but remember it was reflected, so it's okay. That's it for that one. We're doing great. Let's keep going. Number 5. Get my handy dandy notebook. Given the description of the following function, write its equation. The exponential function r has a decay rate of 0.25, has a vertical stretch of 3, a horizontal shift of 4 units to the left, and a vertical shift 2 units. So this guy probably looks like, and I'm making this up, Rx equals 3 for the vertical stretch. Decay rate would be the next thing. we're shifting horizontally 4 units to the left, so that means we need to add 4. Remember, opposites here. And we shift it up 2, so plus 2. That is my formula. Okay, number 6. Given the description of the following function, write its equation. A linear function, k, is reflected over the x-axis, has a vertical stretch of 4, and has a vertical shift of 8 units down. So this one's going to look like k to the x equals negative 4x minus 8. Negative because of reflecting. Vertical stretch of 4. Here's the 4. Shift down 8 minus 8. Put a box around it. Boom. Moving on. 7, in the following equation, in the following equation, what 2 ways can we refer to the negative 7? What 2 ways can we refer to 4? Let's see here. We could say the negative 7 is the y-intercept of the line, so 0, negative 7. It is also referred to as the vertical shift down 7 units. So let me write this out for you guys. Typing is so much easier than writing this stuff. And y'all can read it. So we can say too big. We're going to say the negative 7 is the y-intercept of the line. And remember, that's going to be 0, comma, negative 7. That would be its coordinates. It is also referred to as the vertical shift down 7 units. Referred, there we go, missed the R. Okay, next one is the 4, so let's look at that. The 4 is the slope of the line and is also referred to as the vertical stretch of 4. Remember, it's slope because it's next to the x. Okay, 4 is the slope because it's next to the x, and is also referred to as a vertical stretch. We took notes on that. Negative 7 is the constant, which makes it the y-intercept, and it controls the shifting up and down. So we're shifting down because it's negative. Almost done. Let's look at the next one. 8. Name the function linear, nonlinear, exponential, and the transformation on that function. Make sure to write your answer in a full sentence. So, well, I guess we're going to write the transformations. I think I had this backwards, but that's okay. Let's write it out. So this is going to be exponential function. Oops, too big. I don't know why this keeps jumping up to 36. So, exponential what am I doing wrong here? Exponential function R alright, R, sorry, I feel like I gave y'all the wrong worksheet, not sure. We'll keep going. R has a growth rate of 4, a reflection over the x-axis, a vertical shrink of 1/2, a horizontal shift right, horizontal shift left, okay, opposite because it's a positive 3, horizontal lift 3, horizontal shift left 3 units, and a vertical shift vertical shift down 2 units. So let's recap. We have an exponential function r, has a growth rate of 4, growth rate because it's greater than 1, reflection over the x-axis because of that negative, a vertical shrink of a half, a horizontal shift left 3 units because of positive 3, think opposite, so go to the other direction, and a vertical shift down 2 units. Cool. We're almost done, guys. Number 9, a linear function g is reflected over the x-axis and it has a stretch of 3 and has a vertical shift of 8 units. So, linear function g is reflected, has a stretch of 3 and a vertical shift of 8 units down, minus 8. That was easy. 10, which of the following functions represent f of x equals 8 to the x after a vertical shrink by a factor of 1/4 and a reflection over the x-axis. Well, reflection means we need negative, so this is not it, and that's not it. Now we're down to these two. We needed a shrink by a factor of 1/4. This is not in the right spot. This is 1/4, must be B. Whew, number 11. Is this the last one? Looking good. Consider the function f of x equals 2, and then 2 raised to the 3, x minus 3, parentheses plus 1. Which of the following graphs represents the base function as a dotted curve and the transformation applied to the base function as a solid curve? Okay. So, if you notice, all the dotted lines are the parent functions. So they're all in the same place. So let's look at some key features here. We don't have any negative sign, so this isn't a reflection. So A can't be the answer. Let's see here. We got to shift up 1. Okay, looks like they all do. This looks like a positive growth factor here. So this is decay, so it can't be B. Now we're down to these two. Okay. Now this one's a negative 3. Focus on that right there. We need to, that negative means you shift to the right. This one looked like it shifted to the left. Now I know it's hard to tell because they got this other number in there, but this one really looked like it went left. So we can't take that one. We're going to say D. Process of elimination. Also, when you have these weird looking graphs right there, see that? It's kind of wild. We haven't seen something that crazy. It helps to use that graph feature. You know, graph this function. But also knowing your properties. You know, if you're in a bind, I'll plug this in. But if you know your properties, this one's an inverse, irreflective, so that can't be it because there's no negative. The growth factor right there is greater than 1, so it's not a decay. And just look, this looked like it shifted left. This one, I know it doesn't look like it shifted too much to the right, but I mean, this one is a drastic shift, in my opinion. And obviously that -3 right up there means you need to be going to the right anyway. So to me, it just doesn't add up here. D is really your best answer. And frankly, I wouldn't be surprised if they didn't give you some goofy looking function up here, but expect you to pull out the obvious properties that you need to know. Okay? Well, study hard for this thing. Y'all have a good night, and I'm about to send out a Remind 101 that I posted it. Okay? See ya.